Our problem is going to be about gas laws. The problem we're doing is, in an experiment, the conditions are altered from 4.6 atm, 2.3 liters, and 72 degrees Celsius. What is the ending temperature if the volume becomes 14 liters at a pressure of 1.9 atm? So first we're going to write down our P1, V1, T1, P2, V2, and T2. Each of these means pressure, volume, and temperature. Our P1 was 4.6 atm, our V1 was 2.3 liters, and our T1 was 72 degrees Celsius. Our P2 was 1.9 atm, V2 was 14 liters, and T2 is what we're trying to find out. Before we get started, we have to change Celsius to Kelvin. To do that, we have to add 273 to 72. So 273 plus 72 equals 345 Kelvin. Now we're going to set up a problem. Now we're going to do it with the P's and the V's and the T's. So P1, T1 equals P2 times V2 over T2. That's the basic problem. Now we're going to do algebra to solve for T2. So first what we'll do is multiply this by T2 and put it on this side. Next what we're going to do is we're going to take this problem and we're going to multiply this by T1. Now, to make this easier, we're just going to divide by P1 on this side, and then again you'll divide it by V1 again, and you get your ending problem will be T2 equals P2 V2 T1 over P1 times V1. So that's the problem we're going to use. Now all we have to do is plug in our numbers. So T2 equals 1.9 times 14 times 345 Kelvin over 4.6 times 2.3. And now all we do is simplify. So 1.9 times 14 times 345 equals 9,177. That's going to go over 4.6 times 2.3, which is 10.58. Now all we have to do is divide those. 177 divided by 10.58. T2 equals 867 degrees Kelvin.